now we have strong oxidation of alkenes. Okay. Now first let's start with a simple example. Let's look at propene. Now propene looks like this, right? This is what propene looks like. And if I react propene over here, for weak oxidation, if I wanted to make a diol, remember, we had cold dilute acidified KMnO4. For strong oxidation, we're going to use hot concentrated acidified KMnO4. Okay, you can say acidified KMnO4 ke liye you can say H plus slash KMnO4, or you can say H plus slash MnO4 minus. This anion is the oxidizing agent. K plus is just a spectator ion. Okay, so you'll often see this. This over here means acidified potassium manganate. Okay, or we have manganate ions in acidic conditions. So if you use hot concentrated manganate, okay, in acidic conditions, what you end up doing is you end up rupturing this double bond entirely. You end up rupturing this double bond entirely. Now what happens here? Let's actually partition this into A and B. So what we have here is A, and here you have B, right? What you're going to do is you're going to break this double bond entirely, and you're going to get two different things. You're going to get this guy over here and this guy over here. Now what happens is this. This carbon is bonded to two hydrogens. Okay. Now what you've done is first you've broken this double bond. You've broken this double bond here, right? And what you end up getting over here on this guy, over here is a C double bond O. Okay. And now you have an H and an H, so you end up making methanoic acid. Okay, first you end up making methanoic acid over here, that's A, and then you end up oxidizing methanoic acid further to make carbon dioxide and water. Okay, but this is the key takeaway here. That your final products here are carbon dioxide and water. So when you have a CH2 on a double bond, when you have a carbon bonded to two hydrogen atoms on the double bond, when you rupture that double bond, you end up making carbon dioxide and water. Okay. On the other hand, if you looked at B over here, okay, what ends up happening is this. Again, this carbon where it was double bonded, yahan par you end up getting a double bond O. This CH3, okay, and the H ends up becoming an OH. And what do you end up making here? This is CH3 CO2H, right? So you end up making ethanoic acid. The thing to note over here is that where the carbon-carbon double bond was made, that's where you got the C double bond O. And whenever you have a hydrogen atom, that hydrogen atom will be oxidized further. So if you have two hydrogen atoms, they end up being oxidized all the way to carbon dioxide and water. Whereas over here, since you only had one hydrogen atom, you had this alkyl group, this methyl group, this guy doesn't get oxidized further. Because of this, you end up making ethanoic acid as your final product. Okay. So now let's say that we have, instead of propene, let's say that we're starting with but-1e. Starting with but-1e, right? And if you want to draw this out, you have something like this. Right? This is what we have. Now my question here is, if I react this guy with hot concentrated acidified KMnO4, okay, Or you can say concentrated acidified KMnO4 and heat. Same thing. Hot means I'm heating. Okay. What do I do here? Or if this double bond breaks entirely, what are my products? What does the CH2 give you? This carbon on the double bond is bonded to two hydrogens. So what is this converted to? This is converted to carbon dioxide and water. A CH2 is converted to carbon dioxide and water. And here what you have is you have one hydrogen and one methyl group. So what do you end up making here? Propanoic acid, right? You have a carbon bonded to a hydrogen and an alkyl group. This carbon over here ends up getting a double bond O, okay, where the double bond was, and the H becomes an OH. And you end up making propanoic acid. Okay. If you rewrite this, you get CH3, CH2, CO2H. Okay. So what you've done here is you've actually broken a larger compound into smaller pieces. Okay, you've actually taken an alkene, and through strong oxidation of this alkene, you've actually broken down the alkene into smaller bits and pieces. Okay. Whenever you rupture the double bond, if the carbon atom is bonded to two hydrogen atoms, you end up making carbon dioxide and water. If it's bonded to one hydrogen atom, you end up making a carboxylic acid. Okay. So in the first example over here, what we had was we started with propene. In propene, you have a C on the double bond that you're rupturing. You're breaking the double bond. One of the carbon atoms on this double bond has two hydrogen atoms. Okay, that carbon is essentially converted to carbon dioxide and water. Okay, the other carbon atom is bonded to one H and one CH3. Whenever you're bonded to just one H, you end up making a carboxylic acid. Okay, it's the same thing here. Same thing in this example. You have this carbon atom on the double bond is bonded to two hydrogen atoms that end up making carbon dioxide and water, and this carbon atom is bonded to a hydrogen, only one hydrogen, so you end up making propanoic acid. Okay, now do also note that carbon dioxide is an inorganic product of this reaction. This is the organic product of this reaction, this is the inorganic product. Sometimes a question will ask you, draw the organic product of this reaction. The organic product is propanoic acid. Now what if you have something like this? Now what I have is this guy. Okay. Now what I have is something like this. Okay, now what I'm doing here is, again I'm going to heat this. Again I'm going to react this with hot, concentrated, acidified KMnO4, okay, or MnO4 minus. And I'm going to rupture this double bond. I'm going to rupture this double bond, right? I'm going to break the bond entirely. Now this CH2, what does this end up making? Carbon dioxide and water, right? So in the first case, you end up making carbon dioxide and water. Now what about this guy here? It'll end up making a ketone, right? The carbon with where the double bond was, that carbon will end up getting a double bond O. But then we have two methyl groups here, and neither of them will be oxidized. Remember, only the hydrogen atoms jab hote hain carbon pe, that's when you get further oxidation. So the carbon where the double bond is, you get a double bond O. But these alkyl groups here, in this case you have two methyl groups, they are not oxidized any further. So your final product is propanone. Your final product here is propanone. So if the carbon atom on the double bond is bonded to two hydrogen atoms, you get carbon dioxide and water. If it's bonded to one hydrogen atom, you get an carboxylic acid. And if it's bonded to no hydrogens and two carbon atoms, you end up getting a ketone. Okay. So the last example that we're going to look at is this one. Now what I have is this kind of a ring structure. Okay, and I have a double bond here. And I have this guy. Okay, I have a methyl group on this double bond as well. And what I'm doing here is what I'm doing here is I'm going to react this with, again, hot, concentrated, okay, acidified KMNO4, right? React this with hot, concentrated, acidified KMNO4. And now I'm going to rupture this double bond. Now, will I get a single product or two different products? So what you have here is, if you have an open, if you don't have a ring, strong oxidation में क्या होता है? You end up breaking the double bond and you end up making two separate things. But over here, since you have a ring, all you're going to do is you're going to open the ring up. But you're not gonna get two different products, because these carbon atoms are still connected through this chain over here. Okay. So when you break this guy up over here, what you have here is you have 1, 2, 2, 3, 4, 5, 6 carbon की ring है आपके पास. So let's say over here that this is carbon 1, 2, 3, 4, 5, 6. Right? You have these 6 carbons. This is just numbering shown to make it easy for us. So we have 1, 2, 3, 4, 5, 6. Carbon 1, 2, 3, 4, 5, 6. Right? Now can I say that carbon number 6 over here, right? This is where you're gonna get it. You have a CH, so strong oxidation when you have one hydrogen atom results in the formation of a carboxylic acid group. So this carbon atom ends up becoming a carboxylic acid, and carbon number 1 here, carbon number 1 over here, this guy, the way I've numbered it on the chain, right? This carbon here ends up is bonded to an additional methyl group. So this carbon here is bonded to an additional methyl group, and you end up making what over here? A ketone. Okay, so this is the final product of this reaction. So what we can say over here is that if I have an alkene, over here, right? And when I oxidize that alkene, what I do is I rupture the double bond, right? If the carbon atom on that double bond is bonded to two hydrogen atoms, right? Bonded to two hydrogen atoms. Again, to rupture that double bond, we're gonna need hot, concentrated, acidified KMNO4. Okay. And if I rupture that double bond, there's two hydrogen atoms bonded to that carbon atom. What would my final products be here? So here my final products would be carbon dioxide and water. Okay. On the other hand, let's say that instead of this, what I had a carbon atom that was bonded to one hydrogen atom, and it was bonded to some R group. Okay. And by R group, I mean, when I say R group, it's some carbon containing group. So it was bonded to some R group, okay? And I was to oxidize this guy. If I was to oxidize this guy over here, right? Then what would I get? So now I have same reagents. If I use hot, concentrated, right? Acidified KMNO4, right? The carbon atom, if it's bonded to just one carbon atom and one hydrogen atom, you'll end up making a carboxylic acid, right? And then if that same carbon atom is bonded to, let's say, two R groups, the apostrophe over here is to show that there are two different R groups. R prime is different from R, but let's say it's bonded to two carbon groups. There's no hydrogen atoms bonded to this carbon atom. Okay, and when it undergoes strong oxidation, right? And this is again hot, concentrated KMNO4, acidified KMNO4, MNO4 minus, right? Now I'm going to end up with a ketone. Okay, so this is a carboxylic acid in the second case, and the third case we have a ketone. Alright, and that pretty much wraps up strong oxidation of alkenes for us.